So this is the circuit diagram for a C amplifier. Okay. So initially we just connected all 4 resistor to the transistor. So the connection is like this. So this is our transistor symbol, PNP transistor. NPN transistor. The collector terminal is connected to RC. The value is 820, and the base, from the base terminal R1 is connected, and these two RC and R1 get shorted and connected to your power supply. Power supply. This is a variable power supply. Variable power supply, and the negative terminal of the power supply is connected to ground, and from base R2 is connected. The other end of the R2 is connected to ground, and the emitter terminal, to the emitter terminal RE 220 is get connected. That another terminal is the other terminal is connected to ground. So just connect only this portion of the circuit initially and give 10 volts from the power supply, and verify what is the voltage across collector and emitter terminal. The voltage should be always by 2, VCC by 2. The VCC supply get divided by 2, it will get dividing over here. So these two terminal, if you get 5 volts, approximately equal to 5 volts, then start connecting other portion of the circuit. Let us say this capacitor and load and bypass capacitor and coupling capacitor C1 and input signal. So we will just connect it, we will just rig up the circuit in the same fashion. Now tabulate the values, frequency versus voltage. So now from functional generator, adjust 100 Hz and note down what is the output voltage, peak to peak voltage. So from the functional generator, so the maximum range is 200 Hz, and set the frequency is 100, approximately 100, and find it out what is the output voltage. What is the output voltage? So this is the output section, and use the Y position and check it out. So from this peak to this peak, so 1 unit 1.2, we can take 1.2 into 0.5. So 1.2 into 0.5, 1.2 into 0.5 equal to 0.6. 0.6 for 100 Hz, we will get 0.6 volts. Okay. The same way, now adjust function generator to 200 Hz. Adjust function generator from the function generator, keep 200 Hz, and find it out increased output voltage. Increased output voltage. So make use of Y position and calculate what is the peak to peak voltage. 1 unit, 2 unit, 2.24, 2.4, 2.5. We can take 2.5 into 0.5. 2.5 into 0.5. 2.5 into 0.5. 2.5 into 0.5. You will get 1.25 volts. 1.25 volts. Now, though the maximum range is 200 Hz, now we just wanted to keep 300 Hz. So this is not possible. This is not possible. So that's why we go for setting range for 2K. So now keep it in 2K and adjust by using course to 300 Hz. 300 Hz. Okay, approximately equal to 300 Hz. For 300 Hz, what is the output voltage? What is the output voltage? What is the output voltage? So now just using this one, just decrease it. Okay, and Y position, using Y position. So 1 division, 2 division, not 2 division, less than 2, 1.8. 1.8 into 1, 1.8 voltage. For 300, 1.8. So if you keep on tabulating like this the output voltage according to the frequency. So in the mid band frequency you will get a constant voltage. At a high band frequency again you will get reduces, again the output voltage get reduces. So we already calculated for this one for 100 0.8, for 200 1.3, something like this. So here from here onwards, from 2k onwards it will get constant up to 90k, up to 200k. Okay, 200k, then again it will start decreasing. Now for after calculating this one, after tabulating this one, just calculate a gain, voltage gain. Voltage gain is equal to V out by V in. V in is always constant, 50 millivolts. Okay, calculate a gain. Then afterwards calculate a power gain. Power gain is equal to 20 log gain. You just calculate a power gain. Okay, so you will get this arranging of the this values. Now start plotting graph of C amplifier. This is not a normal graph, this is a semi-log graph. So this is frequency, x-axis is a frequency and y-axis is gain. Okay, so start from 0, 5, 10, 15, this is gain up to 40 and frequency. There is the technique over here. So there is a 10 divisions from here to here. Is a one band, for one band 10 divisions. So if you take 100 hertz over here, this is 200, 300, 400 up to 1k. After 1k, for the second band, the difference is 1k, 2k, 3k, 4k, 5k up to 10k. After second band, for the third band, is the difference is 10k. So like that, you just mark it up to 2 megahertz, 2 megahertz, because we are going to take up to 2 megahertz output voltage. Then according to table, you just plot, you just mark all the points. Okay, then join all the marks, you will get a curve like this. Okay, you will just get a curve like this, and where you are getting constant value, the line, from there you take 3 dB down, from there you take 3 dB down and mark a line. Okay, and where exactly cross over this line for the curve, so draw a vertical line, say this is F1 frequency 1, this is F2 frequency 2. The bandwidth is equal to F2 minus F1. So this frequency you are supposed to get 400 kilohertz to 600 kilohertz. So this is your C amplifier output.